Hello guys, welcome back to my YouTube channel, Outstanding Chem Academy. Please, okay, you subscribe to our YouTube channel. Make sure you click the notification button so that anytime we post new videos on this Outstanding Chem Academy, you'll be the first person to be notified. Okay, make sure you leave a comment for us. It's very important. Okay, you have some challenges in any chemistry aspect that you are facing. Okay, quickly send us a comment. Today we'll be looking at another series, another episode of gas laws. Remember, we have started gas law. We are done with Boyle's law, Charles law, general gas equation, ID gas equation, Dalton law of partial pressure, and Avogadro's. Today we'll be looking at what Gay-lussac law of combining volume. Okay, let's dive in together. See Gay-lussac law of combining volume. By definition, Gay-lussac law of combining volume states that when gas react, they do so in volume, which are in simple ratio to one another and to the volume of the product if gaseous provided that temperature and pressure remain constant. In this topic, you might have been finding it difficult for a while, but the good news today is that I'll be solving some exercise, some examples, and believe me, I believe you will enjoy the class and you will no longer have issue with this topic again. All right, I'll just be giving you the secrets behind Gay-lussac law of combining volume. Let's look at some example. All right, example number one, quickly. Example number one states that 80 cm cube of hydrogen were sparked with 30 cm cube of oxygen, both gases at 100 degrees C and 760 mmHg. What is the total volume of the gas left after cooling to the original temperature and pressure? Okay, the first thing to do here is to write the balanced chemical equation. Okay, let's write the balanced chemical equation. Example one, we are giving hydrogen gas, oxygen reacting with oxygen gas to yield also in gaseous state. So there's need for us to balance this chemical reaction. Okay, two molecules, two atoms of hydrogen, then we have two, that's balance. Two oxygen, we have one oxygen, we have to add two here. So we have two atoms of oxygen, which give us the two molecules of water. Now we have two atoms of what? Hydrogen, we're going to add two here. Now this is the first step. You have to balance this, see all of them are in gaseous state. Remember the definitions. Okay. All right, the next thing is for us to look at what are the moles. Let's look at moles. Moles. What are the moles here? This is 2 moles. Can you see it now? This is 1 mole of oxygen gas and 2 moles of steam. That's in terms of mole. We can also look at it in terms of what? Of volume. 2 volume. All right. 1 volume 2 and 2 volume. What does this simply means? That anytime in this question, that anytime two molecules of two molecules of hydrogen gas, okay, is packed with one what? One molecule of oxygen, you are producing two of what? Of water in gaseous state. Do you get that? It's steam rather. You're producing steam. Right. Now what we are saying here is anytime you have two molecules here, you're going to have whatever values you have here, you're going to have half of it. Whatever values we have here also become the same values we have of the product. That's the meaning of this statement. So this equation is the key to what we have in Gay-lussac law of combining volume. You have to know how to write this equation and you have to understand the rudiments concerning this equation. Let me go over it again. Two molecules is giving us, can be two volume, 2 moles is giving us 1 volume, is giving us 2. In other words, if I have 10, for instance, here, by virtue of this reaction, I'm supposed to have 5. I'm supposed to have 10. That's by the way. Okay. Or for instance, here, if I have 20 here, I'm going to have 10 here. I'm going to have what? 20 here. That's what these things talk about. But let's look at what the example says. Example says this is before spark. This is before the spark. Before the spark, we are giving 80 of hydrogen and we are giving 30 of oxygen. We are not giving this one. Okay. Now, after the spark, let's check after the reaction. After sparking, before sparking. So the volume after sparking, now let's check. According to this, the volume after sparking is how many oxygen will be required to burn this. So by this, we can have 30 of this. When we have 30 of this, we're going to have 60 of this. We give us what? 60 of this. Did you get that? What that means is that 2 of oxygen, 30 cm cube of oxygen is required, okay, to burn what? Spark with 60 cm cube of what? Of hydrogen gas. Okay, so let's look at the differences now. Let's check out the differences. The differences there is what? 20 cm cube. The difference is what? 0. While the difference is 60. Now, the question asks is, what is the total volume left? What is the total volume of the gas left? What are the total, let's calculate the total volume of the gas left. Total volume of the gas. Total volume of the gas, we have 20 plus 0 plus 60. Total volume of the gas in this reaction is 80 cm cube. Did example 2. Example 2. All right. Example 2 says, in the reaction above, what volume of hydrogen will be left over when 300 cm cube of oxygen and 1000 cm cube of hydrogen are exploded in a sealed tube? So let's look at it again. So we have our reaction plus oxygen gas to yield steam. Put them in gaseous state. Let's check our volume or mole ratio of the reaction. So 2:1:2. By now you should know how this thing works. So let's say before sparking, okay, before sparking we have 1000 cm cube. Okay, and for oxygen we have 300 cm cube, and we have nothing for this gas. After sparking now, so after sparking, according to this reaction, what are we going to have? 300 of this one will react. What I mean by react, will be born, we require to burn this, to spark with this particular hydrogen. So we are going to have 600. I'm going to have what? 600. So let's do our evaluation. What's the difference between these? We have 1000 minus 600 giving us what? 400 cm cube. We have 0 cm cube and we have 600 cm cube. The question says, what volume will be left of hydrogen will be left? So let's look at it. Volume of hydrogen. Volume of hydrogen left. Volume of hydrogen left equals to what? 400. Okay, we only use up what? 600 out of the 1000 volume of the hydrogen given. 3. Okay, it's a UTME question. Okay, this one says, what volume of oxygen will remain after reacting 8 cm cube of hydrogen gas with 20 cm cube of oxygen? Let's look at it. Hydrogen gas again plus oxygen gas to yield steam. 2, 2, and 1. So we have 1, we have 2 rather, ratio 1, ratio 2. This is the basic thing you need to know when you are solving Gay-lussac law of combining volume. So let's look at the volume given volume before sparking. Before sparking. What's the volume before sparking? We are giving 8 cm cube of hydrogen and we are giving 20 cm cube of oxygen. We don't have any volume of steam given. Okay, let's look at volume after sparking. What's the volume after sparking? According to this, if 20 of this thing react or is used to burn hydrogen, of course we cannot have 40 here because whatever we have here, we must have double of it here according to this reaction. So in other words, okay, 8 of this will be used up. Okay, half of 8 will give us what? 4. Did you get that? And we have what? 8 cm cube in the product side. Now let's look at the volume that is not used up. Okay, this one's already used up. We have 8, we have 0 rather. We have 0 cm cube. We have 16 cm cube. And we have what? 8 cm cube. And the question asks us what volume of oxygen will be left. What volume of oxygen will remain after the reaction. So let's check it. Volume of oxygen after the reaction. Volume of oxygen after reaction. After this reaction, reaction, volume of oxygen left is what? Is 16 cm cube. Did you get that? Hope you are following. 50 cm cube of carbon 2 oxide was exploded with 50 with 150 cm cube of air. 150 cm cube of air. This air contains what? Contains 20% of oxygen by volume. Which of the reactants was in excess? Which of the reactants was in excess? Okay, let's clear the first thing is for us to get our equation. That's I've told you. That's the first thing you need to do. So you have your carbon monoxide in a gaseous state plus oxygen gas to give you carbon 4 oxide. So let's balance our reaction. So 2 carbon, 4 oxygen, and 4 oxygen. This reaction is chemically balanced, obeying the law of conservation of mass or matter. Now we still have 2. As usual, we have 2 volume. We have ratio 2, ratio 1, and ratio 2. So we have 2 ratio 1, ratio 2. But when you look at this, it's a bit different. We are giving before sparking, we have 50. For oxygen, they say 150 of air. There are so many things that are inside the air. Okay, not only oxygen is inside the air, but inside that air, 20% of oxygen. So we have to extract. We have to know the amount of volume of oxygen inside the air. So let's do that by this side. 20% plus over 100 multiplied by 150. If you do that, okay, do that quickly. What do you have? You have 30 cm cube of O2. So the total volume of oxygen, okay, now in the air is going to be 30 cm cube of oxygen. Did you get that now? Okay. So let's now look after sparking or after the reaction. After sparking, according to this, we are going to have, look at it very well. What are we going to have? If I have 50 here, What will I have? Can I have 25 here? Correct. I can have 50 here, 50 cm cube. I can have 25 cm cube, and I can also have 50 cm cube. So what is the difference between this? We have 0 cm cube, and we have 4, that's 5. We have 5 cm cube, and we have 50 cm cube. The question is, which of the reactants is in excess? Which of the reactants? We have two reactants. We have carbon monoxide and we have oxygen gas. Of course, from this analysis, the reactant that is in excess, let's quickly conclude. The reactant in excess, the reactant in excess is oxygen gas. And this is by what? By 5 cm cube. Okay. Make sure always, okay, you subscribe to our YouTube channel. Make sure you click the notification button so that anytime we post new videos on this outstanding Chem Academy, you'll be the first person to be notified. Okay. Make sure you leave a comment for us. It's very important. Okay. You have some challenges in any chemistry aspect that you are facing. Okay. Quickly send us a comment, and email also will be there for you to email us. Thank you for watching my videos. God bless you. You have a nice day. Sign out.